Today we're talking about model selection for linear regression. So we're still in the same part of the course down here, doing regression. We talked about mechanically how does it work, and then how do you get confidence intervals for different kinds of things that you'd want to estimate using a linear regression. And today we're going to talk about why would you set up your linear regression in one way versus another depending on the question you have. So as we know, there are different kinds of questions that we can answer using a linear regression model. There's the descriptive question, where you're just asking about a pattern or an association between X and Y. There's a kind of predictive question, where if you have this model, you can use the predictions at a given point to say what would happen, what would the outcome be for a person who looks like this, who I've never observed an outcome for before. And you can use it for causal purposes. So under certain assumptions, you can ask, if I were to change a particular variable A, what would happen to Y? So what we're doing today is model selection. What variables or terms should I include in the model? So often you have, let's say you have a data set with x1 and x2, and you have a choice here, right? You could run a very simple regression where you just regress y onto x1. So you're going to end up with a model that looks like this, beta hat 0 plus x1 beta hat 1. Or you could do something a little more complicated. You could add the x2 term. You could also maybe add an interaction between x1 and x2, and you could add a square term. There's a bunch of stuff you could do. You could make this model arbitrarily complex. So which one should you be doing in general? And the answer is that it depends on what it is that your question is. What's your scientific question? What are you going to do with this model? And what are the assumptions that you're willing to make?